Okay, good morning. Welcome to the fourth and final day of our press coverage for IJCAI 2015, the 24th International Joint Conference on Artificial Intelligence here in Buenos Aires. I'd like to invite first Steve Chen from NASA, who's going to tell us about how AI systems can help plan complex space missions. Steve.
Thank you. Hi. So I'm Steve Chen from the Jet Propulsion Laboratory and NASA, United States Space Agency. And there are two developments at IJCAI that are very exciting in the space area. First, I'll be talking about how artificial intelligence scheduling has supported the European Space Agency's Rosetta mission to the comet Churyumov-Gerasimenko. So planning out these space missions is very complicated. It involves understanding a lot about the resources on board the spacecraft, the relative position of the spacecraft, the lighting, as well as the location of the comet. And this is very hard to understand and manage all of these constraints. In any one specific medium-term plan that we might look at, there might be tens of thousands of these constraints. The artificial intelligence software helps the mission planners to manage these constraints and come up with plans that enable them to observe the comet, enable all these amazing scientific discoveries that have happened already thus far in the mission, which are essential to understanding how the solar system became how it is currently, and also things like the sources of water and life on our planet Earth. The other topic that I want to mention that was reported on at the AI in Space workshop, which is part of this IJCAI conference, is work on the NASA's volcano sensor web and flooding sensor web, in which we use multi-agent systems, artificial intelligence planning technology again, and also machine learning technology to automatically monitor volcanoes and flooding worldwide and assist in disaster mitigation, monitoring, and response. And this is in support of many governmental entities, as well as non-governmental entities such as the World Bank and the United Nations.
Okay. Thanks, Steve. Next, I'd like to invite Nick Jennings. Nick is Professor of Computer Science at the University of Southampton. Nick is going to tell us about how AI systems can assist in disaster recovery scenarios. Nick.
Hi, thanks Mike. So I'm going to talk briefly about work that we've done on the ORCID project. ORCID is a 5-year, £10 million project funded by the UK Research Council involving the University of Southampton, Oxford and Nottingham. What we're involved with in the project is we're interested in constructing new sorts of computer systems. We term these systems human agent collectives, or HACs. And HACs are about systems where you have autonomous software agents working very closely, in a close-knit partnership with humans to solve complex, demanding problems in dynamic and fast-changing environments. HACs are characterized by 4 main types of attribute. So they exhibit flexible autonomy, so it's neither the humans nor the software agents who are always in charge. That sometimes it's one, sometimes the other, sometimes during the course of an operation, that will change. So that's flexible autonomy. Agile teaming is we want these groups of individuals and bits of software to come back together to work as a team in order to solve a particular problem. The third area is incentive engineering. So in these systems, no one is in control of the whole system, and so you have to encourage behavior, you have to encourage individuals to participate by managing the incentives, by what sorts of rewards that you offer these systems. So what sorts of rewards work well in what sorts of systems. And then the final technical area is around accountable infrastructure. So you've got lots of different information from lots of different devices of different degrees of veracity and quality, and what you want to be able to do is to reason with that. So blend the good with the uncertain in order to try and understand what's going on. So we've built 3 main sorts of applications within these systems using these sorts of techniques. So we've built systems in the area of smart energy systems, in citizen science, and disaster response. And it's disaster response I'm going to talk about today that relates to our IJCAI paper which is being presented this afternoon. So we've built a range of systems that are able to cope with and support modern disaster response situations. So in these situations, in modern disasters, one of the key characteristics is to understand what the situation is like, what's actually happening on the ground, and that's called situational awareness. And in situational awareness, what you want to be able to do is to bring together lots of different sources of information. So some of that might be from social media, some of that might be from first responders on the ground, and volunteers who are helping to solve information and provide services. And you want to be able to bring all of that together to understand what's going on in the situation, in that disaster, as it unfolds. And so it's a continuous and ongoing process. And again, you have good information from trusted sources, you have less high quality information that may be more variable, may in fact be deliberately wrong because individuals are trying to encourage the disaster responders to come their way. So you have to make sense of that situation in order to be able to understand it. And then once you've got an understanding of the situation, then you need to be able to respond to it. So you need to be able to work out which first responders, which volunteers go in which area. And that's what the paper we're presenting in the conference this afternoon is about. It's about how we can plan and allocate individuals to solve particular problems. So you have individual first responders, you have volunteers, and we also have unmanned aerial vehicles, so UAVs in the sky that can help us with these operations as well. So typically what happens is the computer will generate a first initial plan. This can then be modified by responders as the situation evolves. So they might be sent in a particular direction and then actually on the way to discover something that seems more important. And so what you want to be able to do is to continually and flexibly change and rework all of that aspect of the planning. And that's what the technology that we're talking about has let us do. So it operates in a very flexible way. So we've deployed this system. We've worked with a number of first responders, in particular Rescue Global. So some of our parts of this system that we've constructed were used in Nepal to help with that disaster response. And what we're planning to do later on in the year is to do a full-scale deployment with them. Thank you very much.
Okay, thank you, Nick. So that draws to a close the fourth and final day of our coverage of the IJCAI 2015 conference. We've seen some tremendously exciting research results presented this week. We've seen how AI can assist in the development of robots that help elderly people throughout their lives. We've seen how AI can build better automated translation systems that will lead in the end to translation between languages automatically happening on the fly as it happens. We've seen, as Nick's presented, AI being used for disaster recovery scenarios. We've seen, as Steve described to us, AI being used in complex space missions. What this demonstrates is that AI technologies are really being used across the entire spectrum of computer science applications. This is a tremendously exciting time to be an AI researcher. We're seeing new results and new applications every day. So we've had, as well as a spectacular scientific program in Buenos Aires, we've also had a spectacular social program. We've had wonderful tango, incredible meat, and wonderful wine. We've really had a great week, and I think we're going to take the fondest memories of this wonderful city home with us. We're going to reassemble next year in New York. The IJCAI conference is going to be held in New York in July. We're expecting, if anything, an even bigger turnout, and we look forward to seeing the developments that occur between now and then. So thank you for your time.